Q7001-1, which is the correct sequence for recovery from a spiraling, nose-low increasing airspeed, unusual flight attitude? A. Increase pitch attitude, reduce power, and level wings. B. Reduce power, correct bank attitude, and raise nose to a level attitude. C. Reduce power, raise nose to a level attitude, and correct bank attitude. The correct answer is B. When an aircraft is in a spiraling, nose-low attitude with increasing airspeed, the first step is to reduce power. Reducing power helps to decrease the aircraft's speed and prevent further acceleration during the recovery process. This step is important for mitigating the risks associated with excessive airspeed. The next step is to correct the bank attitude. In this situation, the aircraft is likely in a banked or tilted position. The pilot needs to level the wings by applying control inputs to bring the aircraft back to a wings level attitude. This helps in regaining control over the roll axis and prevents further deviation from the intended flight path. Finally, after reducing power and correcting the bank attitude, the pilot should raise the nose to a level attitude. By pulling back on the controls, the pilot increases the pitch attitude and brings the aircraft's nose to a level position. This helps in recovering from the nose-low attitude and reduces the risk of further descent. Q7001-1. If an airplane is in an unusual flight attitude and the attitude indicator has exceeded its limits, which instruments should be relied upon to determine pitch attitude before recovery? A. Airspeed indicator and altimeter. B. Turn indicator and vertical speed indicator. C. Vertical speed indicator and airspeed indicator. The correct answer is A. When the attitude indicator has failed or exceeded its limits, pilots must rely on alternative instruments to assess the aircraft's pitch attitude. In this situation, the airspeed indicator and altimeter are the most relevant instruments for determining the pitch attitude. The airspeed indicator provides information about the aircraft's speed through the air. By monitoring the airspeed, the pilot can gauge the aircraft's pitch attitude to some extent. A higher airspeed typically indicates a nose-down attitude, while a lower airspeed suggests a nose-up attitude. However, the airspeed indicator alone cannot provide a precise indication of the pitch attitude and should be used in conjunction with other instruments. The altimeter measures the aircraft's altitude or height above sea level. Although primarily used for altitude information, the altimeter can also provide some indications of pitch attitude. If the altimeter is indicating a level altitude, it suggests that the aircraft's pitch attitude is approximately level. A decreasing altimeter reading may indicate a nose-down attitude, while an increasing altimeter reading may suggest a nose-up attitude. However, similar to the airspeed indicator, the altimeter should be used in combination with other instruments to get a clearer picture of the aircraft's pitch attitude. Therefore, when the attitude indicator is unavailable or has exceeded its limits, the airspeed indicator and altimeter are the most suitable instruments to rely upon for determining the pitch attitude before initiating recovery. 7055-1. The collective pitch control should be used to 1. Correct for loss of lift during level turns at altitude. 2. Maintain desired engine power. 3. Correct a high rotor RPM during auto rotations from altitude. The correct statements is R. A. 2. B. 1 and 2. C. 1, 2, and 3. The correct answer is C. 1. The collective pitch control should be used to correct for loss of lift during level turns at altitude. When an aircraft is in level flight and initiates a turn, the lift generated by the rotor blades is affected due to the change in the relative wind. To compensate for this loss of lift and maintain altitude, the pilot can adjust the collective pitch control by increasing it slightly to increase the angle of attack of the rotor blades. This helps to generate more lift and counteract the loss experienced during the turn. 2. The collective pitch control is used to maintain desired engine power. By adjusting the collective pitch control, the pilot can control the pitch angle of all the rotor blades simultaneously. Increasing the collective pitch increases the angle of attack, resulting in an increase in the amount of lift generated by the rotor blades. This increase in lift requires more engine power to maintain a given rotor RPM, thus effectively increasing the engine power output. Conversely, decreasing the collective pitch reduces the angle of attack, resulting in a decrease in lift and subsequently reducing the engine power required. 3. The collective pitch control is also used to correct a high rotor RPM during autorotations from altitude. During autorotation, when the engine is not providing power, the collective pitch control becomes crucial for managing the rotor RPM. If the rotor RPM becomes excessively high, the pilot can decrease the collective pitch to reduce the angle of attack and decrease the lift generated by the rotor blades. This action helps to reduce the rotor RPM and maintain it within the desired operating range. Therefore, all three statements are correct. Option C accurately states that the collective pitch control should be used for maintaining desired engine power, correcting for loss of lift during level turns at altitude, and correcting a high rotor RPM during auto rotations from altitude. 7055-2. Large or unnecessary cyclic movements can, under certain conditions, cause A. Flexing of the main rotor blades and possible damage to the tail rotor system. B. Change in the lift component and a partial loss of lift. C. Helicopter to be subjected to Coriolis effect. The correct answer is B. Large or unnecessary cyclic movements in a helicopter refer to significant and abrupt inputs made to the cyclic control, which controls the main rotor blade's pitch individually as they rotate. These movements can have an impact on the lift component generated by the rotor blades. When the cyclic control is moved abruptly, it can cause an uneven distribution of lift across the rotor disc. This uneven distribution can result in a change in the lift component, meaning that the lift generated by the rotor blades is not uniformly distributed as intended. As a result, there may be a partial loss of lift in certain areas of the rotor disc. This partial loss of lift can lead to imbalances in the helicopter's stability and control. It can cause the helicopter to become unsteady, exhibit vibrations, or experience changes in attitude or altitude. The uneven lift distribution can also result in changes to the helicopter's handling characteristics and maneuverability. 7070. To taxi on the surface in a safe and efficient manner, helicopter pilots should use the A. Cyclic pitch to control starting, taxi speed, and stopping. B. Collective pitch to control starting, taxi speed, and stopping. C. Cyclic pitch to maintain heading during crosswind conditions. The correct answer is B. During surface taxi operations, the collective pitch control plays a crucial role in controlling the helicopter's starting, taxi speed, and stopping. To start the helicopter's movement during taxi, the pilot increases the collective pitch. By increasing the collective pitch, the angle of attack of the rotor blades is increased, resulting in an increase in lift generated by the rotor system. This lift allows the helicopter to become light on the skids or wheels and initiate forward movement. Once the helicopter is in motion, the pilot can control the taxi speed by adjusting the collective pitch. By raising or lowering the collective pitch, the pilot can increase or decrease the power being delivered to the rotor system. Increasing the collective pitch increases the engine power output, resulting in more lift and greater thrust, which allows for faster taxi speeds. Conversely, decreasing the collective pitch reduces the power output and subsequently reduces the taxi speed. To stop the helicopter during taxi, the pilot reduces the collective pitch. By lowering the collective pitch, the angle of attack of the rotor blades is decreased, which reduces the lift generated by the rotor system. This reduction in lift, combined with appropriate braking action, helps to slow down and eventually bring the helicopter to a stop.